a genie is out of the bottle. You cannot put it back.
So, what would it be like if we could travel to some of these other universes? What would we see? Some might be vastly different from our own, with properties unlike anything we've ever seen. In fact, some universes in the multiverse might not have light or matter or anything recognizable at all. And there might be other universes with features not unlike the familiar ones we know, but where life takes a completely different form, perhaps communicating in ways we'd find utterly bizarre. And the math shows that if we were able to visit enough of these universes, we might eventually find ones like ours, with a Milky Way galaxy, a solar system, and an Earth. Except with some slight differences. In one, maybe the asteroid that killed off the dinosaurs 65 million years ago missed. And evolution charted a new course. In another, there might be an Earth with people similar to us, but better at multitasking. But there's something even stranger. Somewhere out there, we should find exact copies of our universe with duplicates of everything and everyone. How could this be? How could there be exact duplicates of ourselves out there in the multiverse? To see how, take this deck of cards. It's made up of 52 different cards, and if I deal them, everyone will get a different hand. But over the course of many, many rounds, eventually, some of the combinations will start to repeat. That's because with 52 cards, there's a limited number of different hands you can deal. So if you deal the cards an infinite number of times, then repeating hands are inevitable. And in the multiverse, a similar principle applies. That's because, according to the laws of nature, the fundamental ingredients of matter, or particles, are kind of like a deck of cards. In any region of space, they can only be arranged in a finite number of different ways. So, if space is infinite, if there are an infinite number of universes, then those arrangements are bound to repeat. And since each one of us is just a particular arrangement of particles, somewhere there's a duplicate of you and me and everyone else.
This can be shocking.
It could be that in another universe I was a rock star and my life is much better, or much worse, depending on your opinion of rock stars.
That means all those things that I've never found time to do are maybe being done by some copy of me somewhere else.
I was rather depressed, actually. This picture robs us of our uniqueness.
It is a consequence of the ideas, and the ideas seem very well motivated.
Yet, critics argue the multiverse is just too convenient an explanation for things we don't understand, like the tiny value of dark energy in our universe and the huge number of possible shapes for the extra dimensions in string theory.
The problem with that kind of reasoning is that it doesn't explain why dark energy is the way it is. It just says it's random chance.
I don't find that satisfactory. You can apply this kind of reasoning anytime you don't have a better explanation.
On the other hand, supporters of the multiverse point out that sometimes a better or deeper explanation for the way things are simply does not exist. Take, for example, the Earth's orbit around the Sun. We find ourselves at a distance of 93 million miles, perfect for life. If we were much closer to the Sun, our planet would be too hot for life as we know it to exist. And if we were much farther from the sun, it would be too cold for life. So why are we in this sweet spot? Well, starting in the late 1500s, the famous astronomer Johannes Kepler asked that very question. And he spent years trying to find a physical reason, some law of nature that requires the Earth to be 93 million miles from the sun. But Kepler never found it, because it doesn't exist. There isn't any physical law requiring the Earth to be 93 million miles from the sun. It's simply one possibility of the many you'd expect to find in a universe we know is full of solar systems.
You might think it was an extraordinary accident. It's not. It's just that there are a lot of planets out there.
Similarly, some suggest that the true explanation for many of the fundamental features of our world will elude us if we don't consider the possibility that we live in a multiverse.
Clearly, if we had a good physical reason, that would be great, and we would understand it. We'd be much happier.
We may have to live with that. There's no principle built into the laws of nature that say that theoretical physicists have to be happy.
It's a hypothesis. It's the leading hypothesis because nobody has another hypothesis which makes as much sense.
The multiverse, a tantalizing possibility. But with no experimental evidence, should you believe it? We can't believe in anything until there's observational or experimental support. But what we have found over the last few centuries is that mathematics provides a sure-footed guide to the nature of things that we haven't yet been able to see, observe, or experiment with. Math predicted things like black holes and certain subatomic particles long before we ever observed them. And math is suggesting that there may be these other universes. That doesn't mean it's right, but often it's leading you to a deeper understanding of reality.
If you choose not to believe it, that's perfectly fine, because we have not given you any evidence yet. And one of the wonderful things about science is it's about evidence, it's not about belief.
And some scientists now think we might just be able to find that evidence. They propose that if our universe and another were born close together, the two might have collided. That collision could have left its own fingerprints, ripples in the cosmic background radiation, the heat left over from the Big Bang.
My guess is, yes, that in 100 years we will know one way or another whether these ideas are right.
100 years from now, it may be an amusing historical episode. We don't know. But if you only work on the things that are already well established, you're not going to be part of the next big excitement.
If we do verify the multiverse, it would change our perspective much as Copernicus did 500 years ago when he showed that the Earth is not the center of the cosmos. And some might say that if our universe is just one of many, our descent from the center would be complete.
Regardless, I think it's more important just that we're so lucky that we can understand the universe.
I think it's a great ride, and I think it's really good for physics that we have this tension. I don't know where I'm going to end up.
So, what does this all mean? Are there infinite duplicates of you and me and everything existing right now in an infinite number of other universes? Is the multiverse the next Copernican revolution? We don't know, at least not yet. But if the idea that we live in a multiverse proves true, we'd be witnessing one of the most exciting and dramatic upheavals to our understanding of the fabric of the cosmos.
Major funding for NOVA is provided by David H. Koch,